Can you pinpoint the 10 security gaps in your attack surface that account for 90% of your risk? It's impossible using a combination of scanners, pen tests, breach and attack simulation tools, and manual processes. But attackers can find your gaps. They perform recon and target the weaknesses with the best return. The Psycognito platform sees your external attack surface the way attackers do, eliminating blind spots. Powered by a global bot network, the Psycognito platform prioritizes your highest risk security gaps, integrates with existing workflows, and reduces operational costs. Visit securityweekly.com/Psycognito. Qualys has brought together vulnerability management and patch management, letting security teams discover vulnerabilities and apply patches immediately, all within a single, unified app. Sign up for a free trial of Qualys VMDR, vulnerability management, detection, and response today at securityweekly.com/Qualys. Welcome back, everyone, to Paul's Security Weekly. We are more than happy to announce that we will be at InfoSec World 2021 in person, October 25th through the 27th. This year, our annual partnership with InfoSec World is extra special. We are both business units under the Cyber Risk Alliance. What does that mean for Security Weekly listeners and InfoSec World attendees? You get to hear and see from many of us at the Security Weekly team, or in the Security Weekly team, I should say. And at the event, you save 20% off your World Pass. You can visit securityweekly.com/ISW 2021, registered using our discount code. This segment is sponsored by NetSparker. Before I get into that, I did want to introduce Mr. Jeff Mann, who is here with us remotely. Mr. Jeff Mann, nice to have you.
Hey, Paul. Thank you.
Adrian Sanabria is also here with us remotely. Adrian, welcome.
Hey, thanks. Looking forward to it. It's a topic I don't know a ton about, so I'm looking to learn some stuff.
Yeah, we were talking about that. It's pretty funny. Cache poisoning. Anyway, before we get to that, this is sponsored by NetSparker, by Invicti. You can learn more by visiting securityweekly.com/NetSparker. It is the DAST scanner of choice here at Security Weekly. We still use it to scan some of our sites, which is great. Joining us from Invicti Security is security engineer Timur Guvenkaya. Did I get that right?
Yeah, I mean, to some extent, so
Close
no worries.
Close enough.
That's a no.
Right.
Close only counts in horseshoes, hand grenades, and pronouncing people's names. Right? Timur has a 3-year history of managing security of web applications, APIs, conducting security code reviews on various programming languages. He joins us today to discuss web cache poisoning. Timur, welcome to the show.
Welcome back. I'm happy to be here. Thank you. Thank you very much.
It's nice to have you. You know, it's interesting when we talk about web caches in general. I was just stating before the segment that oftentimes now it's just like a checkbox somewhere. Like there's a bunch of sites that I manage on a particular platform where I can just push a button and it enables the cache. And I don't get any other options or visibility. I know there's other options out there when you go to various CDN providers and or open source providers. Varnish is a big. Is that open source?
True.
Is Varnish open source?
Yes, it is. What you can do with Varnish, the good thing about it, you have a configuration file where you can basically, and Varnish even has its own programming language at some sort called like a VCL, if I'm not wrong. There you can just code the configuration file in the way that you want your cache to behave to avoid any caching issues. Or if you're not careful, you may even introduce some. So
right. And do the like Apache and Nginx also have modules and options for web caching? I want to say I've seen that in my day too.
Yeah, exactly. I mean, web cache poisoning comes in very different flavors. You might have a reverse proxy like Nginx that's going to do your caching. You can have internal caching. You can just implement your custom one with Redis inside of your web application. So
gotcha.
Just there are many choices that you can pick from.
Cool. I'll turn it over to you, Timur, to go through a little more of the background on caching and then discuss some of the attacks that we've seen surrounding web cache poisoning.
Sure. Let me just share my screen super quickly. Okay, here we go. Today I'm going to be talking about web cache poisoning and how incorrect implementation might lead to some security vulnerabilities. talking about like web cache poisoning and how having this may introduce some devastating consequences for your web application. Let me just go through agenda really quickly. I'm going to be talking about caching in the beginning, just going into deep so you'll understand that it's more than a checkbox on the WordPress. So then I'll dive deeper into cache keys, how they work, why they're important, and how incorrect usage is going to introduce web cache poisoning. Then I'll just talk briefly about web cache poisoning, give you some intuition, show you one example, and then I'll go a bit more deep into that, into ways how you can poison the cache. And then we're going to wrap things out with some web cache poisoning prevention methods. So what's the caching? Caching is just a...
Before you jump into this, Timur, I just, as the resident old timer, I just wanted to ask a quick question. I am more familiar with cache poisoning from a generation or so ago that was more about DNS spoofing and DNS cache poisoning. My silly question is web cache poisoning at all related to other forms of cache poisoning, or is it a completely different animal?
I mean, concept is similar, but still it's a different thing. For instance, the browser caching, let me just give you an example. Web cache poisoning is different from just the regular browser caching. Browser caching is going to maybe store the cached, let's say,
Locally.
static files locally. But in the web cache world, it's going to be stored in a cache server, not on your browser, but on the web application side. So yeah, it's a kind of a different animal. So that's why.
Okay.
Similar concept though, Jeff. Yeah.
Okay, so the concept of what's being exploited or taken advantage of is the same, but it's a different implementation, if you will.
Correct.
Fair enough. Thank you.
So let me just continue. Let me just give you some intuition about what's the caching about. I'm going to give you intuition about like a general caching, not specific to web caching. I mean, caching is just the process of copying data in temporary storage. Why temporary storage? Because you can then afterwards, or depending on your rules, erase cache, purge cache, or just, for instance, in the web caching mode, we can have a cache control header that's going to control when your cache automatically going to get purged. So yeah, that's, since you basically, let's say in the Redis, if you store your cached responses in some sort of array, accessing an array is basically a constant time. You can just directly access it. That's why it provides a super quick access to data, and therefore you're going to receive a response almost immediately. And then, I mean, just an example of the you basically, if you visit the website or web application for the first time, most of the times all the images or static files are going to get cached by a browser. So when you're going to visit a second time, you don't have to wait for images to load. Sometimes even you probably notice on the Chrome browsers, if you don't have an internet, it prompts you to just, can you view a cached version? You're just going to click on it and it's going to just output the whole cached version of the web page, even though you don't have an internet connection.
Yeah, and so like you said before, the browser does some caching, but also there's caching on the server side, right?
True.
Where even though I haven't been to that site before, it loads faster because it's cached on a CDN or content delivery network that's closer to me, and it's not pulling those images from disk every time they're loaded in memory on something that's close to me, right?
Yeah, and obviously if you have all of this, it decreases bandwidth usage, and you're just gonna receive everything super quickly. I mean, that's the power of it. I mean, you want to have your users to have a nice user experience. You don't want your users to wait all the time for huge images to load. So, I mean, it's an obvious choice that it's an obvious reason why many web applications are implementing some sort of caching. And that's the web caching mechanism. It's oversimplified version. In the next slide, I'm going to go into more details. But here, user sends a request. This, let's imagine it's a web caching server. I just put it out of, it can be inside of the server like a Redis, it can be a reverse proxy, anything. I just put it here, so it's going to be easier for us to see. So user sends a request. In this case, that's the first time user visits the page. Request is passed to the caching server. Caching server is like, that's the first time I'm seeing this request. I don't have a signature for it. Let me just forward it to the web application. And then while forwarding it to web application, it's going to save that signature. And then application is going to send a response to the user. And also a response is going to get passed to the caching server, so that it's going to get mapped to a signature. We're going to talk about those signatures, quote unquote, which are called cache keys, in a couple of slides later on. But here, the second time the user visits a page, caching already knows this request from the cache key. In simple terms, just signature of the request, and then you're going to receive a cached response almost immediately without cache server needing to pass the request to the web application. And then let me go to more details. Here you can see more detailed view of the process, how everything works. User sends a request to the caching server. Caching server is going to extract a cache key from the request. In other words, a signature of the request. After I cover cache keys, it's going to just, everything going to come together. Then it's going to just match it to keys that already stored in the caching server. It's going to just go all over them and see if do I have a match there? If I do have a match, I'm going to just send a response matching to that cache key directly to a user without passing it to the web application. If I don't have it, okay, let me just save that cache key and then pass the execution to a web application. And the application will send a response, and the cache server is going to map that response to the cache key, so that next time when user visits, I can just serve a response directly.
And Timur, in this example, a cache key is really just a hash of some of the data in the request, right?
Yeah, exactly. I mean, there is. I'm going to cover cache keys in more detail, but for now, it's just imagine when you're going to take a hash of the request, but you're not taking the hash of the whole request. You're only just taking a hash of certain parts that are enough to identify that request.
Gotcha.
For instance, you don't have to know everything about the request to identify whether this request is basically trying to access the same resource.
And just a quick question on the architecture of this here. Is this typically all done by web server software like Nginx, or might you have like a Redis or a MongoDB storing some of these keys?
Yeah, I mean, look, if Redis has basically, if you implement, it depends on the architecture. As I said, you can have a Redis inside of your direct web application, and when this guy is going to be just inside of the web application, the request is going to be passed, and then inside those requests, with all the cache keys are going to be saved in the Redis database, and then basically it's going to be inside of the web application. If there is Nginx, yeah, it's going to basically Nginx has some modules that just provide caching for you, and it's going to be just in the middle as a reverse proxy working. Or you can have a Varnish, which is almost exactly the same. This architecture is just like a general architecture, like simplified version, so we can get an intuition about the caching. Obviously, depending on the way you implemented it, it's going to look different, but the concept is exactly the same. Nothing is going to change. All right, so, okay, we landed on the website. We landed on the web application. How we know if the caching is there? How we know if the application caches our requests? I mean, there are many ways. The easiest way, if we have those headers in the response, we can directly tell that, yeah, it has some sort of caching. For instance, if we get like X Varnish cache, we can even say that it uses Varnish. And the other method is basically you're going to measure time from between responses. First time when you land on an application, you're going to measure response time when you receive it, and then you're going to resend the request. And after you resend the request, if you get it like, if you, for instance, in the first request, you receive the response like in 2 seconds, but in the second request, you receive the response like in 0.25 seconds, then like there is a high chance that web application is actually caching your request. So yeah, that's the way you can determine whether the caching used in the most simple way. Do you have any questions so far, or should I move to the cache keys?
No, let's talk about cache keys.
Yeah. All right. So cache keys. Just as I said, cache keys is a signature of the request, basically, for the caching mechanism. It's not just you are not computing a hash. Like for instance, in many caching servers, it's as simple as just taking relevant parts and appending it, concatenating it in the one string, and that's going to be and then it's going to be a cache key. So it's super simple. And cache keys are the essential parts of the request. I mean, by essential, I mean we're going to come back to that in a second. Essential parts of the request that lets us determine whether this request is trying to access the same resource. So, for instance, here in orange, usually in web applications, the path is inside of the cache key. Host is inside of the cache key. So in this case, the cache key is going to be just concatenation of this and that. If I send exactly the same request and I add, for instance, here another header, let's say I add origin header with some random values or something else that is not in the cache key.
I want to ask some crypto-related questions here, but I fear that it's overkill.
Yeah, I don't. I had the same. It doesn't seem to me like it's a key or a cryptographic hash either. Right? I think that it's just naming.
It's just a string.
So, I mean, intuitively, the fact that there's not a lot of, it sounds like there's not a lot of mystery or secrecy involved in how these cache keys are created. Is that not sort of the problem here?
That's part of it. Yeah, it's good.
Yep. Yeah, I mean, we're gonna move to. I already mentioned the essential parts, and the way you determine those essential parts are going to determine whether you're going to have web cache poisoning or not. It looks simple, but it's sometimes hard to implement in terms of.
Are the ways that the essential parts determined, is that a constant, or is that change for each?
Yes, it's changed for each web application, but they are default ones. Okay. I mean, in 99.9%, the path is going to be included, and query parameters are going to be included in the cache key, and the host is going to be included in the cache key. But the rest usually varies from the web application to web application. Some application might include cookie, some application might not. And when you don't know exactly what to include in the cache key, that's when the web cache poisoning arises, that I'm going to be talking in the next slide. And here, unkeyed inputs are called and parts that are not in the cache key are called unkeyed inputs. For instance, here, unkeyed input is the user agent. It's not in the cache key. It's not concatenated to that part and this accept and cookie, etc. and etc. That's just a cache key. Here, if we come back here, if I send a request, then it's going to just compute the cache key by just concatenating those parts.
Mm-hmm.
Those parts. And then it's going to search from its basically database to determine whether I have this inside the whether I already encountered it,
Yep.
whether I have it. If I don't have it, I'm gonna just save it. It's gonna be just a key. If you know like in programming dictionaries, it's gonna be a key, and the value is gonna be response. And here the key is gonna be the cache key is gonna be a key. Then I'm gonna send a response. The web application is gonna send a response, and the response is gonna get appended to relevant already saved cache key as the value. Basically, we're gonna have a key value pairs, cache key and the response. That's what it is. And the beauty of it, it's like super simple. There's nothing. I mean, you can just, as I said, append it. It's just a string. I mean, obviously.
So to clarify, because it looks like on your little diagram there that the cache key is never sent to the user's browser. It's all happening somewhere in the middle, or is it sent to the browser?
That's a good question. There are some implementations where, and it's more advanced techniques that I won't be talking here, but sometimes cache keys are sent to a browser in headers like x/cache, and there is a cache key which is concatenated version of this. And sometimes it might introduce other vulnerabilities or let us exploit unexploitable cross-site scriptings. That's a nice question, and unfortunately, I won't be covering this in detail because it's more like advanced techniques. But
Gotcha. Sorry,
yeah.
I'll try to keep my question simple.
No.
No, I mean that's okay. If you have time,
not,
I'm more than happy to explain.
Yeah, it's not really a key like we think of in cryptography so much as it is just a unique identifier. Yeah.
Imagine it as a key in the dictionary, like a key value pairs.
Yes.
Okay, so finally, let's go to the web cache.
It's more like a token.
It's a token or an index. Unique identifier.
Yes. So, web cache poisoning. Here we go. So, web cache poisoning happens when the unkeyed input or the input which is not included in the cache key is reflected in the response, and that response gets cached. That's when the web cache poisoning arises. And I'm going to show you an example in the next slide where you're going to understand it better. But for now, it's just unkeyed input. For instance, the origin header, or I don't know, let's say some other esoteric header that is reflected in the response, and that response get cached. So that is going to introduce a web cache poisoning. I'm going to show you an example. It's going to be more clear. And web cache poisoning, as I said, is not just, I didn't say it, but web cache poisoning shouldn't be treated more of like a standalone vulnerability, like command injection or cross-site scripting. It should be treated more. Sorry, yeah.
I was going to say this sounds kind of similar to stored cross-site scripting in the sense that the idea is you're going to get the server to save something, and then execute for someone else.
Yeah, but the fact you can make the web server store something doesn't mean it has a cross-site scripting vulnerability. Like, it also has to have a cross-site scripting vulnerability in addition to a cache poisoning. Is that right, Timur?
Yeah, is that right? I mean, one of the features of web cache poisoning that you can turn reflected cross-site scripting into stored ones. So yeah,
gotcha.
So yeah, it's as dangerous as the vulnerability you chain it with.
Right.
So, and the cache is going to stay poisoned until it's purged manually or expired. So yeah, here is an example. Let's say cookie is not in the cache key. Okay, we have this in the cache key. Let's say host in the cache key. I should have actually highlighted those, but okay. And we send a request, and depending on the language value, we're going to receive either hi there in English or in Spanish, hola, or whatever. So yeah, here we sent a request with the language English. We got a response with a hi there. But for the caching server, if I just change it to language to Spanish, ES, I'm going to receive still hi there. Why is that? For the cache key, since it's not in the cache key, since it's unkeyed input, it's not concatenated into a cache key. For the cache key, those two requests are exactly the same, since hosts are same, paths are same. So from the standpoint of the cache key, those both requests are exactly the same. That's why it doesn't matter whether I change it to language ES or EN. The first request that's going to get sent is going to get cached.
So Timur,
yeah.
Does that mean that unkeyed header values don't get cached?
I mean, yeah. I mean that's the definition of the unkeyed inputs.
Right.
Those are not included in the cache key. So if in this case it's going to be if let's say we have get in the cache key, like the path in the cache key and the host in the cache key. Cache key is going to be totally real site. Is it for real equals to true? And example.com just concatenate it together. And here also we have exactly the same thing. Cookie is not in both of them. So from the cache key perspective, from the caching server perspective, those both requests are exactly the same. So when I send the first request, and the unkeyed input, which is here, gets reflected here, or change the response in some way. For instance, if I would have sent here first ES, I would have received Ola here, and if I send here English, English is gonna get state Ola as well.
Yeah, the first response gets cached, and since your first response was the language English, that's why the cache response is always in English, even though I changed the language. I got you.
All right. Do you have any more questions? I can move to the.
No, keep going. I get it now. Sorry, I'm a little slow on that one.
No worries. So cache busting. What's the cache busting? Basically, cache busting is artificially changing the cache key in a way that it won't affect the functionality of the web application. If I know that in the 90% of the websites, path and the query parameters are in the cache key. And I know that most of the times the origin is in the cache key. I mean, it's just statistically speaking. That's an accept also. If I add the cache bust with some random value in here, is it going to change the response? Is it going to change anything in the web application? Most probably no. But it's going to change a cache key. If it's going to change a cache key, I'm going to get that response passed through the caching mechanism directly to the web application. I'm not going to get stuck to the caching. And you might ask why we should do that. Because when we test for the web cache poisoning, we don't want to poison the cache of legitimate users. That's why we're doing this. If I, for instance, poison a cache with, let's say, let me just go back. If, for instance, if there is a cache poisoning here, if I would have added here a cache buster, like here origin with some random value, only user with that origin, a random value, is gonna get poisoned, not the all users. So let me just recap. Is there an example here somewhere? So you can't see it directly. Okay, let me just recap on that one. Okay, here we have let's assume that the path is in the cache key, host is in the cache key, and we have origin is in the cache key, but I mean, the application is not using it. Sometimes they just include, depending on the existence, it's going to get included on the cache key or not. So we have origin in the cache key also. We want to poison the cache. We want to test for web cache poisoning, but we don't want to poison the cache of the whole web application so that all users are going to get affected. We are good guys. We just want to get a POC and just send it to vendor so that vendor can fix it. For that reason, we're going to include origin here with some random value, as in here, for instance. We're going to include it. And the cache key here becomes this plus origin. And if the cache gets poisoned, we're going to receive the hi there here only if the request contains that origin. For normal users without origin, they're going to have here hola with the language Espanol. Is it clear for you, or should I?
Yeah, I mean, so in this example right here, if I send someone a link, like I poisoned the cache with that request, I can send them a link so when they visit, /blog ? Cache bust, the response gets served from my origin, not the original website, but maintains same origin policy. Would that bypass same origin policy?
I mean, I just gave the origin as an example. It's there are more quirks, but let's move from your example. Let's say we have a poisoned cache on the ? Cache bust, whatever. We have a poisoned cache there. Only users who visit that exact path are gonna get malicious response, but not users who visit just blog or users who visit something else. We are doing this because we just want to get a POC that web is accurate. We actually managed to poison the cache, but we don't want to affect all the users. We don't want all the users to get cross-site scripting. That's why, because that's dangerous. So that's the reason. One of the reasons we are using cache busting. Or sometimes, let's say you're already testing your application and you decided, oh, let me just test web cache poisoning. Most probably, if there is already caching in place, since you visit the web page a lot, most of the requests are going to get stuck to the caching, and you won't see any reflections on the response. Maybe there is a cross-site scripting, but it's hidden behind the cache. So you're adding a cache bus, so your request is actually going to get passed to the web application, and you're going to see a real-world, real response, quote unquote, coming from the application, but not from the cache. That's another application of the cache busting. Is it clear for you guys, or do you want me to give more?
No, that's clear.
All right, let me just then move forward. So clues when the cache is busted. If there is a if there is a response header, if there is like a caching related response header, such as Xcache, Varnish Cache, most of them are going to have some sort of value called hit or miss. If there is a hit, you hit the caching, you are getting a response from cache. If there is a miss, you're getting response from the web application. If you have it, super simple. If you have a miss, you are getting a response from web application. You are getting a hit, you're getting response from the caching server. Or again, time difference. If before the cache busting you were receiving a response in 0.2 seconds, and after you added those cache busters, you received a response in 5 seconds. Yeah, most probably you busted the cache, and you're getting response from the web application and not from the caching server. Here's the example. Here's the regular request, and in response we have some headers, and we have Xcache hit. Yes, we are getting this response from the caching server. And after I add some cache busters, I'm getting a cache miss. That means that response is coming from the web application.
Sweet.
Okay, let's move to the cache poisoning methods. All right, so reflected unkeyed headers. There are many like esoteric headers, like for instance xforward host, that might get in that the application might read to perform some functionality, and there are many more, and sometimes they are not included in in the cache key, but they affect the response. And if that happens, we're gonna get the cache poisoning by default. For instance, here, the application reads the X forwarded host. If here we had like secure.com, we would have received secure.com/blog, just as an example. But since we included that header with the script alert 1, and there is a cross-site scripting inside, we received script alert 1 /blog, and that response got cached. And now if I remove this value, it's gonna get still cached, since from the caching perspective, we only have this in the cache key and that in the cache key, assumingly. This in the cache key and this in the cache key. For the caching mechanism, both of those requests are exactly the same, even if I don't have this X-forwarded host. So now if the user visits that path, that user is going to get cross-site scripting, even though it was reflected in the first place.
That is until the cache resets or times out, right? So you have to keep resending these requests every so often to make sure that your response with your cross-site scripting attack in it was the one that's in the cache, correct?
Mm-hmm, mm-hmm. And that's correct. And how you can purge a cache. For instance, in the Varnish Cache, you can send a special header called purge.
Nice.
Where and how it's structured is purge only accepts the. You can specify in the default configuration from which hosts you are expecting the purge come from.
Mm-hmm.
You're expecting it only from localhost. You're expecting it from the, let's say, from the dedicated IP addresses that you trust. If just random user tries to send a purge header, it won't take any effect. That's some precautions against that, against misuse, and or the cache control headers. If there's cache control headers, it has max age, and after max age, that specifies amount of time before the caching expires. So
right,
if time passes, caching is going to expire automatically. So yeah, and that was the simple example with some headers. Here is I think that's one of the most interesting ones. Oh, sorry. So Ankit port. In this case, let's assume we have some sort of redirect in the web application. We visited we wanted to apply for a job on a /careers apply, but it actually moved to a jobs apply. Let's say just some random example. And we notice that the host header is reflected in the location header in the response. What we did, we just appended the host here, and we saw that it also appends host inside of the port. Also appends the port inside of the location header. This port is probably not used, so if I just click redirect, just send that request, I'm probably gonna go nowhere, and I won't be able to access the page. And just imagine if that actually gets cached, what's gonna happen? Any user who tries to access that path is gonna basically get some sort of denial of service, so that no one will be able to access that particular path. So that's one of the interesting quirks of the web cache poisoning, because from the caching standpoint, if the host, actually that part is not included in the cache key, from the caching standpoint, both of the requests are exactly the same. Both of them have this and that. That's all. This and that.
And that's interesting, because it's a denial of service on the client side for the browser. It's not actually attacking the web server. So I'm not sure if a WAF would be very helpful here. Would even be looking at this.
I'm not sure. I don't think so. I mean, from my experience,
That'd be a pain to
I-
troubleshoot.
Yeah.
yeah. I'm like thinking I haven't seen any WAF that detects web cache poisoning of some sort or similar to those issues. I don't think so. Because I
Right.
mean,
I mean, nothing looks like an attack here. Like
yeah,
there's
that's why I was
no-
like thinking, how can you even detect it? I mean, you're just appending a port there.
Yeah, I mean it's a 5-digit change that just
Yeah.
breaks the redirect. And I mean denial of service can be so much simpler and harder to detect than like if you're trying to do command injection or something like that. Like that can be fairly obvious.
Yeah, true. I mean, in this case, honestly, that's one of my favorite attacks that web cache poisoning can.
That's sneaky.
Yeah. It's super. I mean, that's just an amazing one. Yeah, there was the second method you can poison a cache. If you have redirects, yeah, try it out. I mean, it doesn't matter if it's a host. Maybe there is something else that's reflected there. You can play around, and maybe you can achieve the denial of service some another way. Let's say, let me just move to the next one. So, unkeyed request method. Okay, in this case, let's say. Okay, in this case, let's say we have the page and it accepts both, let's say, get and post requests, and the caching engine or caching web server does not include the cache a request method to a cache key. It doesn't matter for the cache key whether it was get or was it post or was it something else. So yeah. In this case, let's assume the original request is the get request, and it was like a get, a queue cat block, blah, blah, blah. Everything works cool. And we see that queue actually gets reflected there. And what we can do is, and we also notice that when let me just go back. Sorry. Here we go. Okay, and we notice that if we add the same parameter to the body, it's also getting reflected. In that case, what you can do is there is also a kind of like a let's say parameter pollution. The application gets confused and uses the wrong parameter here. But if that's the case, there is a get request. You saw that if you add the parameter to a body, it also gets reflected. What you can do is you're going to change the request method to post. In this case, you're going to pass the exactly same parameter, but with your payload. It's going to get reflected in here. And if the user tries to access the exactly the same page using a get request, is going to get a script alert one. Because for the caching key for the caching server, it doesn't matter whether I send get or post request. This one is not included in the cache key, but content length is not included in the cache key. I only have that guy and this guy, let's say. And if I send this, both of these requests for the cache key is exactly the same. And if I send this first, it's going to get cached, and I'm going to receive this back.
Cool.
Okay. I mean, if cool.
I get it. Yep, I get it.
Okay, if cool, I'll just move forward. This one basically exactly the same, but we are relying on the fact that application accepts fat get requests. What are the fat get requests? Those are just get requests with a body. Most of the web application or frameworks do not accept it by default. For instance, Varnish does not accept it. But if we encounter the web application that accepts it, we can try it out. Exactly the same concept as here.
That's content before you're opening an HTML tag?
What? Sorry.
When you say fat get request, that means there's content before like the HTML starts, or content in the header?
No, I mean fat get request. I couldn't get it. I mean that's just a get request, and I just add the body. That's all to it.
Oh, okay.
That's Yeah, that's about the request itself. It just I'm thinking that this get request is actually a post request, and I'm adding the body to it, which is not, I mean, how it's supposed to work. And sometimes web application get confused. And
Right, but that's outside of anything else in the request where your HTML tags are, right? The body's almost like inside the header.
Yeah. Okay. Yeah, that's what I add. It gets reflected here, and if I just remove it, it's gonna persist in there. Also, you can try with the XHTTP method override. If I add this header, I can, if the application does not accept fat get request, I can force the application to treat that request as a post request by adding this header. XHTTP method override post, send everything. It's gonna be treating this request as this, for instance.
Right.
And yeah, that's the one way to bypass if the application doesn't accept fat get requests. I mean, worth a shot. So the next one, Ankit query string. I think that this one is the most dangerous one, but it's easily detectable. I don't think not many applications are going to do that anyways, but still worth mentioning. We do not include the query string into the cache key. What I mean by that, I don't include the author equals something. I don't include name equals something. I only include that part. Super secure books and host example.com or something else, doesn't matter. That's all. If that's the case, if there is a vulnerability like reflected cross-site scripting in here, let's say in author script alert 1, I send it here. In this case, even in case of this web application, let's say I'm filtering books, and if I just hit the books path without any query parameters, I'm just gonna get some list of the books, let's say, that are exist in the database. And in this case, if the query string is not part of the cache key, and if there is a vulnerability reflected cross-site scripting in a search, then, and if that's the case, this response is going to get cached. And if the user just tries to browse books without just filtering them or searching them, they're going to receive this cross-site scripting issue directly on this whole path. And just imagine if we found the cross-site scripting somewhere on the root path, what's going to happen? So yeah, that's kind of how you can turn a reflected cross-site scripting to a stored one. Obviously, this is super easy to detect. I believe. I mean, if the web application has some sort of bug bounty program, probably it's going to get detected in the first 20 minutes or so. But still, I mean, it's worth mentioning the impact that web cache poisoning might have. Do you have any questions about that?
If the parameters change on that GET request, doesn't the application have to output a non-cached response? In other words, my author, in my request /books, author equals 1 versus author equals 2. If it just pulls the first response out of the cache, it's going to be author equals 1, not author equals 2, right?
Yeah, I mean, technically, yes. If in this case, since the query parameter is not in the
cache key, right?
Yeah. So, sorry, it's not in the cache key. In this case, yeah. I mean, if I would have sent the author 1 first, and then afterwards I would have sent author 2 first, I would have received author 1 here.
Right.
Yeah, that's the thing. That's why it's super easy to detect. Probably after some QA, people would have recognized that issue. I mean,
but I'm sure there's more advanced configs of caching to cache the other elements on the page, but not the response. Right?
True,
in modern web applications, right? Your data and your requests are broken up, so I could tell to cache the top of the page with the header, but don't cache the responses that are coming back from these queries in the database or whatever.
Yeah. I mean, you can even specify, I want to just cache this. I don't want to cache anything after ampersand. If there's ampersand, I don't want to cache anything.
Right.
Something like that. Okay. So let's move to the prevention part. I just covered the most, let's say, easy to understand and the high chance of encountering, obviously apart from the last one I just showed, so that you can understand the impact that it might have. So yeah, let's move to the prevention. I'm going to be using just Varnish Cache as an example, since you can configure it however you want, and it's going to be easy to see. Normalizing a host header. Just remove the before caching the request. If there is anything in a host header, such as port, etc., just strip it out and then cache it. We don't want that. Sorry, we are normalizing the header. Basically, we're normalizing a host, and you can even specify if there is, in a Varnish, you can specify if there is a port. Obviously, if I'm not expecting it, if there is a port, just pass it directly to our application. Don't cache it. Don't do anything. There is something called pass, so you can do whatever you want with this one. We don't want to have a host in the response. When you're sending, sorry, apologize. So when you're sending a request, it's gonna just strip the host and send you back the response. It's or you can, as I said, specify just a pass here. That's one of the examples of how you can prevent the denial of service. It's, by the way, by default, if you download the default configuration of the Varnish Cache, you're already gonna have most of those things set. And that's amazing. Do not reinvent the wheel. Do not try to code the default configuration of Varnish Cache by yourself. Those guys probably know better how caching works than you do. So just trust them. Just download their default configuration. Just tweak some other stuff. For instance, I'm expecting a request that might have the port in the host. Okay, fine. Remove that. Add the host to the cache key, and whenever someone adds a host, it's going to be a different cache key, and that request won't get cached. You're going to just receive a response like in the real world, kind of. If I just host with the 1, 2, 3, I'm going to receive a response with 1, 2, 3. If I remove the host, I'm going to receive a response without so if I remove the port, I'm going to receive a response without the port. Since it's in the cache key, every time I add a port, cache key is going to change, and everything is going to be new. So yeah, just do minimal tweaking to that default configuration. You don't have to do much. It's a good source of truth. And caching get and head request. You saw examples what happens if you cache if you don't include the request method to a cache key, or you just trying to cache post request. I'm not sure whether you should even cache post request, because post request, when you send a post request, it's always going to update the data on the server, so it shouldn't be static by default. So I mean, there is no point. You're just going to introduce vulnerabilities by doing that without getting a lot of gain out of it. So that's
weird stuff in your application, like you're saying. Post requests are usually because I'm sending the server data that I want to change or update.
Yeah, exactly.
So it doesn't make sense to cache it.
Can I ask a potentially dumb question?
No worries.
I'm sure you can.
What you just did? Is that
okay? Fair enough. The
only dumb question is the one you don't ask.
Right. Okay. So let me ask it. How is it common? Is it normal for the client to add headers and to change headers?
What do you mean by
In mid-flight, like how we're doing the tampering here. You're potentially adding headers, that weren't there in the original request. Like some of the X headers, for example.
I mean,
Is that fairly common for the client to do, which makes it trickier to defend against, these manipulations?
I mean, obviously, it's not common for just if you're a regular user, you probably won't be able to do that. I mean, you're just browsing the web.
Right.
That's all. But
Yeah, I
but
don't
if
think
that's, I mean, if
Well, I
that's
think
the
that's part
But I
of
mean,
the
does the
exploitation.
browser do it?
Yeah, I
Like,
don't
is
think
it normal for the browser?
And correct me if I'm wrong, but I don't think the browser changes the header request organically. If you're just browsing the website, the server will introduce new headers to tell the browser about how to behave. The browser can ignore those, but typically the browser doesn't introduce new header items. Isn't that?
Well, I think what
Typically.
we're essentially saying or asking is there a trust relationship essentially between the web application and the browser? And I think the answer is yes. The reason why all this stuff works is that there is no expectation that there's tampering with the header
Right.
request, the headers
Right.
or the request.
So what I'm getting at there is, should we be suspicious of any changes to header coming back or additions of headers?
I mean, that's
yeah. I wouldn't want to be responsible.
That's a philosophical
Yeah.
questions, kind of. I mean,
Because the other thing too is every browser and every version of every browser could potentially have different headers, and browser plugins can also influence those. So
yeah, true.
Yeah.
I mean,
Plugins. I've seen plugins. do it.
that's why it's super unfortunate. I mean, if you would have configured your web application firewall to do that, I mean, you would have blocked many valid requests, I suppose.
Right.
If you just
Yeah, and that was kind of my question: is alerting anytime you see a new header added that's not, that you don't typically see. Like, is that going to be 1 million alerts a day or none?
That's a good. There are people we can ask. Obviously, Timur and Nespark are on the other side of it. It'd be interesting to ask people that are on the other side and providing a WAF style that's looking at all of the HTTP requests and responses. Certainly, there are those vendors out there. If they do something like that, Adrian, it's a good question.
Yeah. Now, I could totally see, like, if you're using, like we talk about SASE a lot, like if you're using reverse proxies and authenticating through proxies and stuff like that, like I would expect, or doing some kind of TLS inspection, I bet that messes with all kinds of stuff in headers.
Yeah. I mean, unfortunately, I won't be able to answer. It's like, as Paul said, I mean, I'm on the other side. I'm not sure how many. How many
Well, I mean,
alerts
it's
going to pop
food for
out.
thought for the audience, right?
Yeah. No, it's a good.
Just something to think
question.
about.
Yeah. So, okay. Let me just then, I mean, as I already mentioned, you can just specify pass and it's just going to send it directly to web application. Okay, again, do not allow fat GET requests. Varnish Cache by default does not allow them. I mean, is a fix, I suppose. Fix client-side vulnerabilities. As I mentioned before, web cache poisoning is as dangerous as the vulnerabilities it chained with. So if you fix a lot of client-side vulnerabilities, you don't have any cross-site scripting, etc., or like, let's say, client-side template injections if you're using some sort of view.
There's a nutrition joke here somewhere. Only allow low-fat or no-fat GET requests.
Yes.
No fat, low fat, zero fat.
So
okay,
I think what Adrian was trying to get at. Let me try to ask the question a different way. In your opinion, is the way you prevent these types of attacks primarily through I don't know if coding techniques or programming techniques is the right term here, but doing things the right way in terms of how you are managing your web applications versus is there, given that people don't always do this, is there a recommended way of, or is there a good way of detecting this type of activity? So, the question I think is, the ounce of prevention versus if you can't prevent it, can you at least detect when it's happening?
Okay, let me give you the most solid answer. If you want to just eliminate web cache poisoning, just do not use caching. Like, that's the simplest answer I can give. Unfortunately, it's not applicable. The solution is not applicable for majority of the web applications, unfortunately. So I'm not sure about the detection. I don't think so that detection is going to be reliable, as we already talked. We're gonna block many valid requests by doing that. Maybe some, let's say in this example, where it was, there was some sort of header. I mean, for instance, if we add like X forwarded host, but no, sorry, I mean, in this example, by default, it's already there. So, okay, a wrong example. I don't think we can detect it, to be honest, reliably.
That's fair, because I think that's what I'm getting. That's what I'm hearing you imply, is that nobody wants to go down that road. There's not a good way to do it. What we haven't said is just how much overhead would be added to try to add any kind of checks to this. Nobody wants to do that. That's what I'm hearing.
Yeah. I mean, web application. I mean, I would be surprised that there will be a web application firewall that will detect web cache poisoning with less than 50% of false positives. I'm going to be super surprised.
Yeah, I mean, one of the things I find interesting here is one of your defenses looks like you're sanitizing input. But this is not somewhere we expect to see input from the client side.
Right.
Mm-hmm. Yeah, I wanted to ask, I don't think that what you're describing here today is on the OWASP top 10. Are there parts of the OWASP top 10 that apply here? Or is this technique in the OWASP top 20, top 50, top 100?
I'm not sure. Look, this attack came. The first blog post about this attack was, if I remember correct, that 2018, and the most recent one is in 2020. So I don't think so. I haven't checked, to be honest, but I don't think so. It's included in the OWASP top 10. But some parts of the OWASP top 10 is like the cross-site scripting, let's say. I mean, you're gonna be. Actually, no. I mean, recently I saw there was some blog post on the OWASP top 10 about web cache poisoning, but I don't think it's included in the official like OWASP top 10. There is a separate place for the web cache poisoning. So
so where OWASP puts it is under host header injection.
Yeah.
Okay.
I think that's the right spot for it.
Which is not the top 10, I don't think.
No, it's definitely not. And
I
mean,
which makes
I mean, it's this attack like is super recent. That's why I don't think so. I mean, if I remember correctly, in the most up to date OWASP, they just included SSRF as a separate in a separate place. If I'm not wrong, so we probably should expect if web cache poisoning is going to persist, and it won't get fixed by default in many vendors, and many people are gonna. If it won't just decrease to the minimal levels, we might expect it be in OWASP top 10 maybe in the next version. I don't know, in the 2023 or something like that. So that's
I actually found a write-up, at least on Well, I think it's on web cache poisoning at the OAuth's website. I'll try to make sure this link gets added to the show notes so people
Sweet.
that want to know can read all about it.
Thanks, Jeff.
Yeah. They have a blog post about it. And the last part. I mean, we were at fixing client-side vulnerabilities, and the last part is disabling caching headers. At least, I mean, obviously it's not optimal, but at least you're gonna give attacker a bit of a hard time determining your web caching functionality, what parts of the request you cache, etc., etc. If you are not seeing whether you're hitting a cache or not through a header X cache hit or X cache miss, I mean, it's sort of a security through obscurity, but still, it's kind of a giving a bit more hard times for an attacker to determine how your caching works, so that it can, so that he or she can exploit it. That's one of that's another measure, but it's not a measure, it's just a complementary thing. It has to be done with other measures as well. Yeah. So thank you for your time. And do you have any more questions?
Questions, guys? No?
I think I'm good.
We asked a lot of questions
good.
throughout the whole segment. So
We're not shy.
yeah. Timur, thank you so much for appearing on the show.
Good. Thank you for having me. That was super nice.
For folks that want to learn more, you can visit securityweekly.com/NetSparker. And that will conclude the show for this evening. Thanks everyone for listening and watching. We'll see you next time. Over and out.